So there are many different record types, and the record type A is the old one, IP address. NS is the name server. So for example, bushtel.edu, who is the name server for bushtel.edu, right? And when you send that question, you will say, I want to know the question type NS. CNAME. CNAME is canonical name. Now, what is a canonical name? So many of you are called Bob, but your canonical name is Robert, right? So canonical name is the real name. Okay, Bill, Williams, anything. So basically, so the idea is when you say www.bushtel.edu, the www is the name actually of the host, whose real name may be very different, whose real name may be, just pick your name, whatever you want, right? But we call it www because we know that that is a web server. Okay, so many of the hosts are given a name based upon the function they are doing rather than their real name. If you want to know their real name, you ask for CNAME. Is that clear? And so for example, when you say smtp.google.whatever, that SMTP is not a real name. It's a name, but if you want to know the real host name, because there are many hosts in google.com, and if you want to know the real name, you have to ask for CNAME. MX is the mail server for that domain. Who is the mail server for that domain? And so you can ask, and there are other types. We will just go through 4 types for now. And so in the DNS, actually, inside the server, they have a table, and the table has the name, the value of that name, so type A, and the type of the name, and the TTL. TTL is something that we will use quite often in other contexts. TTL stands for time to live. And time to live means that how long is this answer good for? So if the answer is good for 3 days, just like if you remember in the web server, there was a time to cache. How long can you cache this answer? Similarly here, the answer is good for 1 day, 1 month, or 1 year, or 1 second. So TTL. So for every record there's a TTL, and after that the answer is old, they have to renew the answer. They have to find the answer again. All right, so the message format. So how do you ask DNS and how do you get the answer? So you send a question, and the question will have something like this. It will have ID, that this is a DNS question, flags, some flags that we'll discuss. But then they say, I want to ask 5 questions, so number of questions. Okay. And if it is an answer, then it will be number of answers. Number of authority RRs. So these are authoritative answers and additional answers. Okay, by the way, RR stands for response and resource responses. So the thing is, these RRs, these answers, some of them are authoritative. And you know what is an authoritative? Anybody remembers that? What is an authoritative answer? So nobody has read the book. I can guarantee this. Okay, first. Second thing is, nobody remembers from the last lecture. Monday, I explained authoritative and non-authoritative. Now, anybody remember? Trying to make your point. If you want a class participation point, you better go and read these things at home, and that way it becomes more permanent than just listening to the class. Authoritative answer and non-authoritative answer have to do with some answers we are just giving you from my cache. I really don't know the answer. And some authoritative answer we have to go all the way there to find out from the people who are maintaining that answer. So if you want to know what is the name of the 3rd child of Mr. Robert, whatever, you have to go to Robert and ask. what is your name of your third child? Maybe they had a fourth child, and the third child has become a fourth child. Who knows? So that is authoritative answer. For authoritative answer, you have to go all the way back. And this was the thing about here. If you want an authoritative answer or something, you have to go all the way to the source. Non-authoritative answer, these guys can give just from their cache. Okay? So a number of authorities. Anyway, and then these are the questions and the answers, and who the authority, who actually, where it came from, and additional information. So other information might be like IP address of the canonical name in the MX response. So even though you asked for the mail server, the next thing you will ask is what is its IP address? If I gave you just the name, SMTP dot whatever, SMTP dot something, right? So they give you that already. So IP address might be given as well, along with the name. So this is in both directions. As you can see, this has the questions and the answers. And so when you send it, basically number of questions would be there, and the questions would be here. The answers would not be there. Answers would be 0. When the response comes back, the questions will be there and the answers will be there. Okay. So when you send to DNS, you send the same kind of message, and the response comes back, which is also similar kind of message. Is this clear as to what is this slide about? All right. Now, where do you register your name? So I told you that all of you should get your own name, domain name, I mean. And particularly if you are going to be, a networking professional, it looks very professional to have your own domain. And so you could have your own domain, and it might be a little bit too late for some of you with very common names because somebody else already has those names. But the thing is, the place, the central place, there are registrars all over the world, and there are thousands of them in this country. But the central registrar is internet.net. And there is a group called ICANN. Actually, in my time, it used to be a person, Postal, John Postal. And if you wanted a name, you just send an email to John Postal and you got the answer, you got the name. All right, John Postal passed away. So now we have an organization called ICANN, which is representative from all the countries into that group, and they manage this whole naming system. And there is this internet.net, a company which manages the whole thing, because now there are millions of nodes and millions of these things, right? So things have changed. But anyway, the registrars provide authoritative name servers, A and MX records for the domain. So you could look up on Google any name registrars. I think there is something called Daddy something. I forget the name. For getting a name, I probably right now I'm registered with something starting with name. I don't remember the name, but anyway, you can figure out who are selling these things. What they do is they charge a slight commission, and then they register you with the internet. So your name is worldwide registered, guaranteed. Nobody else can have that name. But you have to pay every year $10 to $20 a month, $10 to $20 a year, which is a cost. And if you have more than one name registered, you have to pay that much more. Okay. But every time you get a name, for that name, then you can decide what to do with this name. What is the A record, which that means the IP address. What is the MX record, where the mail will go. What is the other answers? You can just decide all of that. Okay. So for example, as I told you, for my name, rajjain.com, if you send any mail to rajjain.com, and it doesn't matter who it goes to, it all comes to me, right? You can send it to x@rajjain.com. You can send it to robert@rajjain.com. It comes to me. But that is how I programmed it, because there is no other user. If there were 100 users, I would have done 100 users, different users, right? And WebEx, if you go for web, I have programmed it so that it comes to my Boostal home. Wushtel homepage. And for my son, I have programmed it so that it goes to his blog. He writes a blog, and if somebody says, okay, www.amitjain.com, it goes to his blog. And so you can see the use of these names. Okay, people don't have to remember very complicated things. They can just remember. For example, my Wushtel homepage has a very complicated thing. It is www.csc.wushtel.edu/Jain and so on and so forth. With rajjain.com, it is just 2 words, right? And actually one word Rajjain, you remember, and then com. Okay. Anyway, so having said that, now you know how to register your name. Any questions about that? Now, some people can attack DNS. So, for example, if some registry, so you're not going to get an authoritative answer oftentimes, and you can just go and ask, okay, what is the IP address for rajjain.com? And somebody can give an answer, wrong answer. Okay, and now it's okay for rajjain.com, it won't do much damage. But if somebody says, what is the address for youtube.com, and it is sent to some other place, billions of dollars will change hands, right? So that is done. So there are bad people who can poison, as we say, the DNS. Okay, so when you take security class, we teach you how to protect and how it is protected. Okay, because in the past, when the DNS was not protected, some particular host in some other country says, I am the youtube.com, and that's the real case. And lots of people ended up there with no information. Okay? Can you think of any other way to misuse these things? What if you were to say that I am bankofamerica.com? Yeah. So what will happen is somewhat, I think you said the same thing, but I'm going to say it again, is that you could prepare a page which looks like bankofamerica.com, because you can copy their page to your computer and then start serving bankofamerica.com. People who will come to your bank, they will log in, username and password, and you say service is not available. Done. Please try again later. And and this is one of the exercises in our security class, by the way. So and the code is actually on my website. So the thing is, DNS can be misused. Actually, it is not so much that we misuse DNS, we just misuse Wi-Fi, because when you have Wi-Fi and you go to a Wi-Fi, I don't want to go into that. The security, there's a whole security class. So anyway, I think DNS, this is sufficient for right now. Any question? Yeah. I'm sorry? Yeah, right. So if you see the network security course, now I don't do this, but in the previous courses, I used to have students do a project. And one of the projects, if you go back a few years, was how to get a fake, how to get a fake website. And by the way, I was subjected to the same kind of experiment when Wi-Fi was coming. Now you're just taking me off track. But when we had Wi-Fi was just very new, 1984, not 1994 or so. I went to a meeting, networking meeting, IETF meeting, and they gave out free Wi-Fi. That time, the Wi-Fi was not part of computers. So you had to have an adapter. They gave out free Wi-Fi adapters. We took it, and in the evening, they published everybody's password. So, this was a lesson. All right, DNS summary. DNS is used to resolve names to IP address. Now you know domain name service, right? Also provides name aliasing, which means you can have many names and you can get the canonical name. You can get MX records. DNS is a distributed database. Now you know it is a database, but it is distributed. Why distributed? Because it's all over, right? And you can get a recursive query or you can get iterative query. In recursive query, they will find the answer and bring it to you. In iterative query, they may not be able to answer you, but tell you that, okay, go and ask him. So that's the difference. Iterative means just tell me where to ask. And then there is a root server, which is on the top. There are top level domains like com, net, edu. Those are the top level domains. And then there are authoritative server for each domain. Okay. All right. So question, the homework 2C. DNS. Is it possible for an organization web server and mail server to have exactly the same host name? Now this is very trivial. I'm not going to go over this. I think you should be able to figure that out. What would be the type of RR that contains the host name of the mail server? Okay. And please do read the book, because if you don't read the book, even though I said it, it comes here and goes out that way. Okay, so it doesn't stick too much until it is read many times. All right, so I'm going to move on unless there is a question about name server. Yeah. Okay, so the question is, the recursive query results in an authoritative answer? The answer is no. Actually, recursive, all it means is somebody has the answer. Now, it may come back with non-authoritative answer. Now, if you want authoritative answer, you just say that I need authoritative answer, then in that case, it will go all the way. It will take some time, but you will get it. So recursive simply means get me the answer. Iterative means that if you don't have it, don't worry. Just tell me where to go. All right, so we go to P2P. And then P2P, basically, we will talk about, and most of you have done BitTorrent, right? Okay, everybody has done BitTorrent, so you know what is P2P. P2P is peer-to-peer. We'll talk about that, how it works. But basically, and actually, BitTorrent is not just for bad things. Actually, Windows 10, if you want to get an update, nowadays it comes by P2P. Okay, and most other companies are using P2P to distribute whatever they're distributing. And we will teach you here why that is better than the old way. So if you want to get, most of the other computer companies as well, they provide their software via P2P because it is much less expensive than supplying it from central place. So how does P2P works? Basically in P2P, there are many hosts and they might have either complete information or some piece of the information. So let's say you're looking for a movie. So somebody may have the whole movie or maybe part of the movie. Okay. And so and then basically, so you ask them what do you have, and they will tell you that I have piece number, actually we call them chunk. We have chunk number 5, 7, and 13. And then you ask somebody else, and you ask somebody else. And as long as you can get the whole list from 1 through 100, you say, okay, I'm all set. Give me these chunks. Okay. And but how do you find who has any chunks? For that, everybody who has a chunk goes and asks from tracker. So there is a single computer, actually not a single computer because there are many trackers, but you go to a tracker and say, hey, I'm looking for this movie, who has any pieces of it? So it will send you a big list. All right. Now you have a big list and then you decide whether to use the whole list or part of the list. I mean, there might be several hosts and you do not really want to connect to 2,000 hosts. So you can select 10, 5, whatever. And then you start trading. Now trading means that once you get something, you have to give it to. Okay. And everybody is measuring how much you are giving. If you're not giving, they will not give it to you. Okay. So that is the whole way, is that you give it to other people give it to you. And that's how the trading works. Yeah. What are you giving to them? Once you get it. So let's say I got one chunk number 1 from him. Now I tell everybody knows that I tell them that I have chunk number 1 and 5. So I give them whatever chunks I have. Okay? And you don't have to have the whole file either to be giving. So basically, when you start downloading, you start uploading at the same time. Okay? And once you have finished downloading the whole file, then you start seeding, right? Seeding means that I have the whole file. All right. So now I will show you mathematically that this is better than the other method. Okay? And this one, so we are going to use some symbols and I need to put all that math in place. So let's say n is the number of peers. So we have u1, u2, and un. U means up, d means down. So there are n peers. Okay? F is the file size. And we want to, and the movie size is 200 megabytes. Nowadays it is even gigabytes. So let's say 2 gigabytes. Okay, file size. UI is the uplink speed of the IF host, and DI is the downlink speed of the IF host. Okay, Dmin is the minimum of the down speed, and then capital D CS is something which is more than NF upon US and F upon UN. So this will come up later on basically. But what it is saying is CS is the central server. If everybody went to the central server and said, give me that 2 gigabyte movie or 8 gigabyte Windows 10, okay? If everybody went to the central server and got that file, then the time to get that file would be more than the maximum of this. Now let's see what is that. N is the number of users which want that file. F is the file size. US is the speed of the server. Server can upload it only at that speed. So you can see that the total file size, because there are n people asking for it, it will have to send n copies of F, n times F divided by US. That is the speed. The download time would be more than that, right? For all of them. And it will also be more than F upon D min. Now, one of them is very slow. They have 100 bit per second connection. If they're very slow, the total time will be F upon D min. Right? So, to the central server, the total time would be more than maximum of these two. With P2P, it will be maximum of these three quantities. So let's look at the three quantities. F upon US. All right? F upon US, server's speed. So a server has to provide the whole file, and the speed is US, so it cannot be less than that. Right? F upon D min. It cannot be less than D min. I mean, if somebody is very slow, we got to give them the whole file. So that is the time. And NF upon US plus sigma UI. Now, this is something that really requires a little bit more thinking. So NF, because F bytes will be uploaded to each of these hosts. So we have NF, total bytes uploaded. And US, server has to upload, and UI, all of these guys have to upload. Upload means coming to them. Sorry, upload means coming to the network. Okay, download is coming to them. So this is the time cannot be less than this. Okay, and therefore the P2P times is more than those three. And if you were to plot this, you will find that the time for the client server goes up very fast as the number of users goes up, and with the P2P it goes up very slow. So just think about this is not 35 people who are downloading Windows 10. There are 35 million people when the update comes out. Right? So with P2P, you can get it in minutes and hours. With central server, it takes weeks. And that why P2P is good. All right. So BitTorrent is one of the P2P protocols. So there are many other protocols. There were many other protocols before that. And BitTorrent, which was actually designed by a student like you, became very successful because he thought of some things that were good and new at that time, and now they are standard. So let us see what he thought of. So first of all, we know peers. Peers are all the nodes that are participating. Okay. Now the peers can be of, and the torrent is the set of all peers. So all the people who are participating, that is one torrent. Okay. And their directory is kept at the in the torrent directory, and then torrent file, a file containing the information, that is the file that we are looking for. And files are segmented into equal size chunks, and the chunk size is 256 kilobyte. Okay, so this is of course this person designer decided that we should not be dealing with small size chunks. Chunk is 256 kilobyte. And seeds are the peers that have the complete files. Okay, and the leechers are the ones that have incomplete files. Okay, so when you use BitTorrent, you will see the numbers of both. I mean, for every file, it shows how many seeds are there and how many leechers are there. Okay, and then tracker has the list of all the peers. The whole list is here with the tracker. Tracker knows everybody who has any piece of any file, of that file. So let's say Alice uses, actually I had my lectures on P2P for some time. Now I've given up on that one. But I can distribute my lectures using P2P. I mean, many people do because the files are bigger, like 10 megabytes. And people in India or some other countries, they want to download 10 megabytes from US, it's kind of difficult. Okay. But if it was P2P, they would download it right from there, right in that country. So let's say Alice uses torrent directories search engine to find a torrent for Raj Jain's lecture. Okay. Alice contacts the tracker to get the list of all the peers, and trackers may provide, let's say, up to 50 peers. Okay. Alice sets up TCP connections with these peers in parallel and gets a map of available chunks. So she contacts those 50 people and says, what chunks do you have? And they tell what chunks they have, and she makes a map that, okay, how many copies of what chunks are available from where. And request the least available chunk first. Now this is a smart design decision that the BitTorrent designer did, that when you want to get a file, don't go for the chunks that are plenty, that are available in plenty. Find the one that is the least available. If there is one chunk, only 2 people have it, try to get that chunk first. Rarest first. You can see why it is good, right? So that is rarest first. Then every 10 seconds, Alice calculates the receiving rates. So now I randomly selected these people, and I see, okay, this one is sending at 1 megabit, this one is sending at 10 megabit, this one is sending at 100 megabit. So who should I talk to more? The one that has the highest speed, to me, right? So every 10 seconds, it calculates the receiving rate and sends to top 4 senders. So out of all these, there are 4 people who are sending me the fastest. I say, okay, all right, you are my friends. I will give you more. You see? So, and now it may not be the same movie. It may be some other movie that they want, that you have. So preference is given to those who are sending to you. That means unchokes the top 4 senders. Every 30 seconds, Alice sends to one randomly selected peer and optimistically unchokes. So now there are hundreds of people who are asking for something, and I don't know whom to give. So I will randomly take one person and say, okay, let me see if you're a good guy or bad guy or bad girl or whatever. And I will give it to you and see how much I get from you. So that is a random. So you just don't stay on 4, you take one randomly. And that is called optimistic unchoke and helps find the high rate neighbors. So with this process, if you continue with this process, what will happen is that you will get the people who are in your country, people who are in your city, people who are in your state, rather than going to some other world and trying to get that file from there. Because those people, even they have the file, but they are far away, the total speed is very low. Okay? So that's how BitTorrent works. Any questions about that? And how many of you have done BitTorrent? Nobody raises his hand, huh? You guys are pretty much backward because, I mean, this is DNA. Yeah, go ahead. Actually, here's what I'm going to, I'll tell you what I was going to say. I'm going to come to your question. If you have done any business with Microsoft, you have done peer-to-peer, except that it was all hidden inside the Windows. Okay, go ahead. Okay, you have to say loudly. Okay, all right. So, all right. So I did not. So here's the thing, though. This is one thing. Everything, every technology that is developed can be misused and can be used. Right? If I develop a cloth, it can be used for wrapping guns, and it can be used for wrapping people. Right? So BitTorrent can be misused for illegal stuff. When I said have you done BitTorrent, I didn't say that have you done it for illegal stuff. There is a lot of legal stuff. Like my lecture is totally legal to download. Right? And any big file like Windows 10 that Microsoft wants, it's totally legal to download it from Microsoft. But they don't want it directly, they want it to get you by P2P. So yes, if you do illegal downloads, and that's why none of you raised your hands because I know most of you did that, but didn't dare to raise your hands. So the thing is, yes, what will happen is if you did, so those trackers, those other people, they know who is doing what, right? And there could be national security agency, government, or whatever, CIA. And they could figure it out that you are downloading this illegal copy of this movie, and then you will get a notice, right? Now, when you take network security class, we teach you how to not get that notice, but not right now, okay? Because for every attack, there is a protection, right? And so we teach in the security class also how to attack and how to protect. If you don't know how to do bad things, you won't be able to protect yourself. I mean, that's the thing. So we teach both sides of the thing. We call it red hat and blue hat. Blue hat is the police, red hat is the bad guys. So we have both sides. Does that answer your question? Yeah. So BitTorrent is not all bad. That's what I wanted to say. So if somebody caught BitTorrent on your computer, that doesn't mean that you did bad things. All right. Any question? How it works? Yeah. Well, I mean, the top 4 will keep changing because the 4th one may drop out or maybe log out or whatever, right? So your question was? Oh, yeah. You try your best. No, sitting is, you hope that somebody else will randomly unchoke you, because when you start, you don't have anything, right? Hope, I mean, and you still want to get. So yeah, you might get started. And you will try as many people as you can. You might want to, so let's say even though you are uploading those top 4, you might have 50 others that are sending to you, hoping that you will become their top 4. Okay, so that's the end of P2P. And the summary is P2P applications are more scalable, means when the number of people using goes up, P2P is the way to go. BitTorrent has peers, trackers, seeds, and leechers. BitTorrent unchokes 4 top unloaders and 1 random node for load balancing, right? We know that one random one. Distributed hash tables are used to manage large distributed databases used in P2P applications. Now that sentence I did not include in the slide. For that sentence, you have to read the book. Please read the book. Okay? Because there is a lot more detail and we cannot go through every word in the book here. But what is a distributed hash table will be in the exam. And so you need to read that. Distributed hash tables are used to manage large distributed databases. And then Skype uses super nodes to keep track of active users. And that sentence, again, we did not put it in the slides here. But the chapter, if you read the book, it has a whole section on Skype, how Skype works. Skype is P2P too. Okay, so Skype uses super nodes to keep track of active users and provides relays for users behind NATs. Now, I did not tell you what is a NAT, but I will tell you now maybe a little bit, because even though it is in the book, but NAT requires a little bit explanation. NAT is Network Address Translator. Network Address Translator. So what happens is, all of you, if you check in your home, your computer has an address 192.168.0. something. And let's say 192.168.0.100. Now, I have the same address in my home, you have the same address in your home, you have the same address in your home. So those are called private addresses, and anybody can have that address. But when you go out to the world, you cannot go out with that address, because then the world does not know who you are. Right? So everybody has one address, which is given by your ISP, which is the address that you use to get out of your home. All right. And so when you make connection to Amazon.com, that is the address which is used, that one IP address that your ISP has given to you. And when I go to Amazon.com, even though my computer address is the same, but when it gets out, it is my home address. All right. So this translation, so when the response comes back, then somebody has to figure out which of the 15 computers in my home was trying to reach Amazon.com. Right? Because you send out one address and then the response comes back, and now you have to figure out whether it was my son or me, or who was trying to get to Amazon.com. And so there's a device called Network Address Translator, NAT, and that is built into your router. So you don't have to have a separate box. Okay, when you buy a router, it comes with a NAT. All right. So when you send something, it remembers which computer is sending this. And when the response comes back, the response goes to exactly that computer. Okay. Any question about NAT? All right. So there's your homework 2D, P2P. Suppose Bob joins a BitTorrent, but he does not want to upload any data. Okay. He's playing safe. He does not want to upload anything. And this is called free riding. Bob claims that he can receive a complete copy of the file that is shared by the swarm. Swarm is this whole torrent. Is Bob's claim possible? So please think about it, whether he can do that and why not. Bob further claims that he can further make his free riding more efficient by using a collection of multiple computers with distinct IP addresses in the computer lab in his department, and how can he do that? So if he went to computer lab and 5 computers, can he get it faster? All right. So it requires reading the book, thinking about it, and then answering. All right. The last thing in this chapter is about streaming video. So right now, actually, it turns out the most popular application is video. There was a time when we started, the most popular application was email back in 80s. Then it became the web. So if you went and measured the traffic on the net, internet, it was mostly web traffic. But today, it is the video. Everybody is watching movies. In fact, believe it or not, all the movies, all the TVs, everything that comes in my home comes by the net. Right? Even if you watch a normal standard TV program, they all come by the net. So how does that happen? So video traffic is 80% of the consumer traffic today. And the way video works, and this is something which is beyond networking, is that they show you a picture 25 to 30 frames per second. All right. And in the United States, it is 30 frames per second. In the rest of the world, it is 25 frames per second. Why? Because it is related to the frequency of the electric current. In the United States, the electric current frequency is 60 cycles per second. In the other countries, it is 50 cycles per second. Okay? And someday I can give you a whole lecture of why United States is not with the rest of the world, but not today. Let's just save it for some time. But you will find throughout this networking class and throughout all communication class that the rest of the world is different. But so here we have 30 frames per second. All right. And so basically pictures are like this. First picture, second picture is like this, third picture is like this, fourth picture is like this. But if it is flashed very fast, you see the hand moving. And they did an experiment and they found out that if you do less than 30, the hand looks like this. If you do more than 30, it makes no difference. So why do more than 30? 30 is good enough. It looks continuous. Okay, so 30 frames per second. But the thing is, when I send you this picture, the second picture is exactly the same with very little difference. None of the parts have moved except my hand little bit, right? So why send the whole picture, right? So we can compress. We do not have to send the information which is the same in the previous picture. So the video can be compressed both ways, spatially and temporally. Spatially means if this is red, the next pixel is also red, or whatever color this is. And if this is blue, the next pixel is also blue. So space-wise, if you look at the picture, the same kind of color picture and intensity is being sent, spatial redundancy. If I send you one, I don't have to send you others. I could just send you the difference, 0, 0, 0, 0. And temporarily means time-wise. If you see the picture first one and see the second one, they are very similar. So if I send you the first one, I don't have to send you the second one. I could just tell you 0 is the difference. If the difference is not 0, I can tell you the difference. So it can be compressed. And therefore, the video can be either variable bitrate or constant bitrate. Constant bitrate means that if you have 100 megabit connection, just I will send you no more than 100 megabit. Now change that 100 megabit to 1 megabit connection. I will send you no more than 1 megabit. So that is a constant bitrate movie. Variable bitrate is that whatever you need, whatever is required for the good quality video, we send you that rate. And so there is an international group called Motion Picture Expert Group. So this is part of that ISO we talked about. ISO has a group called Motion Picture Expert Group. It's MPEG group. And they set up a standard, and that standard was called MPEG 1. which produced videos at 1.5 megabits per second. Then they came up with the release 2 called MPEG-2, which was 3 to 6 megabits per second. Then they came up with 4, which is even less. Now, the 4 is better in quality, but lower in bandwidth. And that's why it is most popular right now. Everything that you download today, or most of the things that you download today is MP4, right? MP4 stands for MPEG-4. And MPEG-4 is very good compression without much loss in quality. Okay. And by the way, I must point out that people in the networking business have to keep track of what goes on the network and what people do and all that. So there is a report that comes out from Cisco called Cisco Visual Networking Index. And it comes out every few years. And so this is the one that I put there. I mean, I'm not sure this is the latest one, but basically it tells you what is on the net. And that is where you find out what percentage of traffic is video. All right. And there was a time when P2P was the most traffic on the net. Most people were busy downloading. Now, basically it's the video, which could be just coming as a video. Okay. Anyway, so now there is a standard for video. And let's say you do Netflix or you do Amazon Video or you do YouTube. It doesn't matter which one you do. You might be using this standard called DAS. DAS is Dynamic Adaptive Streaming over HTTP using Hypertext Transfer Protocol. So DAS provides an efficient method of video streaming. Basically, the servers are very standard web servers. No changes required to the servers. Content distribution networks are hypertext transfer protocol. So the good thing about the DAS is that you can start serving video. In the beginning, when the video came about, there were some very special video servers that were required, and we actually had one. And so if you could not really distribute video using web. You really needed this special server, real video, and so on and so forth. And my old lectures were in real video. And so now all that is gone. Now you just need a standard server. What you do is you take your video and divide that into lots of pieces. And when somebody asks for it, you send a piece and they know exactly which piece to request, just like a chunk. Okay. And so content distribution network, CDN. So basically in between, actually now what happens is because the network internet is very big, people cannot just get everything from one place. So there are companies that provide servers all over the world. So Akamai is one name, I can tell you. So Akamai has web servers in almost every city in the United States and maybe every country, most of the major cities in the world. So when you ask YouTube for some particular video, it doesn't have to come from California. It just comes from Akamai server in your country or whatever country that is. That is called content distribution network. That's a service that Akamai provides, and they charge YouTube for that. You really don't see it at all. Okay, it's totally invisible. It's like proxy server. Okay, so content distribution network. But anyway, so the idea is that a table is prepared by the server or by the people putting new video. And this is called media presentation description, MPD. This MPD file says that if you want to receive at 1 megabit, these are the pieces. If you want to receive at 100 megabits, these are the pieces. If you want to receive at 10 megabits, these are the pieces. For every rate, for the same movie, for different rates, there are different pieces. Right? Because at 1 megabit, the file cannot be so big because movie is 3 hours long and we got to do it in 3 hours, right? So the file is very small, it goes low quality. At 10 megabit, it is better quality. At 100 megabits, you get even better quality. If you want to really see 4K video, you got to have good network. Right? So for every rate, there is a list of segments, and this whole thing is called MTD. And once first thing you say is, okay, send me please the MTD. So this is the client, this is your computer, this is your TV. Okay, it gets the whole MTD, and then it starts playing. It starts playing, let's say, at 100 megabits, and then suddenly finds that really there is not enough network bandwidth, so it will move down to 10 megabits. Then finds that there is not enough bandwidth, it moves down to 1 megabit. And then it says, okay, now there is more bandwidth, it goes to 10 megabits. So it can change the rate to available bandwidth. But it knows exactly what point in time the segments start. And if I'm going to do the next one, this segment should I request? It says, okay, please send me the segment number 35. You see what I mean? So that's how this dash works. And so these are simply files that are requested on demand from the web server, and don't have to be video, they could be anything. Oh, content distribution network, I already told you. So the content distribution networks, they are all over the world. And and all the companies like Netflix and so on and so forth, they use these servers. They just pay them for this service. You don't see it. And and it is, the magic is done by DNS. So for example, when you are in Pakistan and you say, okay, what is the youtube.com, it will direct you to the nearest Akamai server. Okay, because YouTube has put that thing that I am going to put it on Akamai server, and here is the, so you will go to the nearest server and not here. And so for example, here, if you're in St. Louis, Netflix.com might go to cdn_stl.com. Okay, or cdn_sfo.com in San Francisco. So they are all over the world, right? All over the in every city. So you don't have to go very far to get whatever you need. All right. So a question about dash. Again, these are very small questions. That's why there are very small points. A dash system stores video at 5 different rates, 15-minute segments. Right? How many URLs will be required for a 2-hour movie? Very simple division. I think you can probably figure it out. So I'm going to move on. So application layer. So we talked about the application layer. We talked about many applications. In particular, we talked about, first of all, we talked about that you can use one of the 2 transports, TCP or UDP. And we saw that HTTP, FTP, and SMTP, all 3 are client-server protocols. So there is a server for all 3, and they use TCP connections. HTTP as designed is stateless. That means the servers do not remember whatever you supposed to not remember, but the way they remember it is by what? Anybody remembers what is that is used to remember your history? Cookies. And so the cookies were invented so that we can remember the whole history of yours. Proxy servers improve the performance. So proxy servers are the servers which are in between, and they keep a copy. And CDN is actually a proxy server in some sense. BitTorrent is a P2P file distribution protocol and uses trackers to keep list of the peers. Then we learned about Dash. Dash allows video distribution by small files. And CDN, content distribution networks, are distributed networks which keep the content cached. Any question about any of these? All right, and please do read the book. Okay, As I said, at least there are 2 or 3 items which I left out here in the class, and you have to read that in the book only, and they will be in the exam. So please read the whole chapter. If you have any question about the things that you read, please ask me in the class. Everybody else will benefit. You can ask the TAs as well, but I think, it doesn't matter. You can ask here as well. All right. Now lab 2B. Now, this is the thing that you just got in your hand, 2-page handout. Okay. If you didn't get that 2-page handout, does anybody who did not get this 2-page handout? Everybody got it, right? You didn't get it. What, do you have an extra one here? Okay, there's one extra here you can take. Now this the original handout said that you have to do 4 programming assignment, lab 1 through 4. We have reduced that to just 1. Okay, this is number 2 of those. It is in the book, socket programming assignment, number 2. And number 2 simply requires you to write a program that will ping another computer. Now it requires writing it in Python.